solving trig equations. Cosine 7x equals 1. They want all the answers between 0 and pi over 2. Oh, sorry. Damn. Is that one open? Nope, that one neither. All right, are we there? Are both of them on? Yeah. All right, guys. This might be kind of tough because it's kind of lengthy. There's 20 questions. I'm sorry. That's just the way it is. All right, here we go. You guys tell me what questions to skip. This one we're not going to skip. We're just rookies. It says cosine 7x equals 1. All of them can be done without a calculator. First thing you do, I like to rewrite the question again. Cosine 7x equals 1. Are we still okay? Then I like to get rid of the cosine because I want to have 7x equals something. So how do I get rid of the cosine? Inverse. I'm going to write 7x equals arc cosine or inverse cosine of 1 plus 2 pi n. Because if you go 2 pi, you're going to be in the same location. Are we still okay? All right. On the unit circle, where is cosine 1? What radian is that? 0 or 2 pi. So you're going to say 7x equals, you don't have to put the 2 pi, just put the 0. 0 plus 2 pi n, see, because the 2 pi n will give us that answer. Divide by 7, everything. Whatever you do to one side, you do to all of them. There it is. What are my answers? Well, one answer is 0, if n equals 0. Another answer is 2 pi over 7. And if you put a 3, I guess 6 pi over 7, but 6 pi over 7 is larger than half a pi. So the only answers are 0 and 2 pi over 7. Does that make sense, guys? Yeah.
How did cosine negative 1 turn into 1 turn into 0?
Sorry, I was drinking my Diet Coke. Remember that means cosine of what angle equals 1? Well, the angle is radian 0. Are you guys excited for a cold on Wednesday? Yeah, me too. I'm going to come to school walking. I'm excited. All right. Bless you square. Bless you cube. Did I answer your question, Henderson? Here we go, guys. Next one. I got cosine 9x equals 0. I want to get 9x by itself. So what do? Inverse. And then add 2 pi n, because when you add 2 pi, you're in the same location. On the unit circle, there's 2 locations where cosine is 0. Where and where? Not 0. Pi over 2, what's the other one? 3 pi over 2. So you're going to write it like this, guys. Write 9x1 equals pi over 2 plus 2 pi n, semicolon, 9x2, that's a subscript, equals 3 pi over 2, because that's what you told me, right? Plus 2 pi n. Are we still okay? All right, I want to get x1 and x2 by itself, so all I got to do is divide by what? 9, divide by 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 9. x1 equals pi over 18 plus 2 pi n over 9, semicolon. x2 equals 3 goes into 9 3 times, and 2 times 3 is 6. So pi over 6 plus 2 pi n over 9. Are y'all okay? Sorry. So now that I did that, look at my domain, guys. 0 to 2 pi over 9. Am I going to add 2 pi over 9 to this pi over 18? Hell no. It's going to take me above the 2 pi over 9. Can I say hell no? Hell yeah, I can say hell no, right? Yeah. Hell yeah, I can. Oh. There it is. I'm not saying any bad words. Should I beep? Should I beep on my YouTube? Should I like boop? No, because then parents are gonna think that I'm actually, yeah. Do you guys watch this during dinner? No. I think you should watch it during dinner. That'll be all you guys can, your parents and you can listen to pre-count. Oh. Okay. All right, guys. I'm sorry for even asking. Let's continue the math life here. Look what I started. All right, here we go. B as in Billy. All right, here we go. Cotangent x equals negative square root of 3. Remember that cotangent is x over y on the unit circle. And I guess you don't have to do arc cotangent, but I am. X equals arc cotangent of negative square root of 3 plus pi n. The period for cotangent and tangent is pi. That's why there's a pi n there. Let me put that for good notes. Period of tan theta and cotangent theta is pi. It repeats every pi. Here's my unit circle. Negative square root of 3. You can get negative square root of 3 by doing negative square root of 3 over 2 divided by a half, or square root of 3 over 2 divided by a negative half. Do you guys see that? All right, here we go. The only way I can get this to happen is if I'm right here. The only way I can get this one to happen is if I'm right here. Remember that cotangent is x divided by y on the unit circle. Cotangent theta is x over y. Still okay? All right, what does that happen? What's this radian right here in blue? 5 pi over 6. What's this radian here in orange? 11 pi over 6. Look for those two answers, and you are done. Some of these questions might be the exact ones. That's fine. Does this help or no? Okay.
What's the point in having 2 pi n if we're not just
Oh, because sometimes, what if this would have been to 4 pi? Then you would have gone, you would have kept going.
so we have to add
Well, I guess in this case, you don't even need to calculate 11 pi over 6. You could have just taken the pi over 5 pi over 6 and added pi, and you would have gotten the 11 pi over 6. The whole point is to keep adding pi within my domain. So if I would have had a 4 pi like that, I would have kept going. Plus pi, plus pi. You know what I mean? No, these are good questions, miss. That was a valid question. Good job. You get a point. Here, you get a pen. You can keep that one. Wow. All right. Are y'all doing okay? All right, here we go. Oh, I'm sorry, miss. Here we go. Next one. Secant squared equals 1. I'm tempted to just go right off the bat and type in cosine squared x equals 1, but I don't know how you guys feel about that. No, okay. I won't do it then. Side note, secant squared x is the same thing as 1 over cosine squared x. It's a reciprocal. I can replace this with 1 over cosine squared x equals 1. See? Times cosine squared x. I mean, I guess you could have also said, what's the reciprocal of that? What's the reciprocal of 1? Times cosine squared x. 1 equals cosine squared x. You get back to the same thing. Are we still okay? Take a square root on both sides. Square root, square root. Cosine x equals plus minus 1. Where is cosine equal to positive and negative 1? Here. X equals 0 and 2 pi. And here. X equals pi. 2 pi is outside the domain. Ask me, Baya. Okay. Ask me, Gouda. Ask me. Okay, very good. Sorry, miss. I'm not having a tantrum. I'm pretty sure. Move the 8 sine x. Sorry, guys. I'm getting a little hyper. I don't know why. Maybe it's the all the caffeine. 8 sine x cosine squared x minus 8 sine x equals 0. Can we do that? What can I factor out? The sine x and the 8. 8 sine x, there it is factored out, giant parenthesis, cosine squared x minus 1, close it, equals 0. Yeah, I did. I did slow down. We already did this one in the middle. I think I did. I think we did. The only way that will equal 0 is if cosine squared x equals 1, and we just did it a little while ago. Square root, square root. Cosine x equals plus minus 1. Don't worry, I'm slowing down. What's up? Ask me. Ask me, Herrera. These are the locations where cosine is 1 or a negative 1. It's where the same locations that we did a little while ago. Look at that. And by coincidence, those are also the same locations where sine x is 0. I guess you don't have to write 8 sine x. Divide by 8, divide by 8. Where is sine x equal to 0? All the same locations. So x equals 0, pi, 2 pi, n pi, where n is any integer. Yes, ma'am. What did we what? What happened to what? What about it? Yeah, I just figured it out. So if 8 sine x is 0, 0 times anything is 0. So if 8 sine x is 0, I need to know where sine x is 0 because that's how you get 0, right? I'll stop. No. If 8 sine x is 0, then all this is 0. 0 times anything is 0.
Wait, how did you get 8 times 0? You just figured that was 0.
It says here 0. So if it equals 0, then I have to have 8 sine x equals 0, because 0 times anything is 0. Did I answer your question? And I don't really care about that 8. As long as sine x is 0, 0 times anything is 0, right? If you want to be technical, divide by 8, divide by 8, 0 divided by 8 is 0. So where is sine x equals 0? But I don't want you to be a robot. I want you to understand. Do you know what I mean, Henry? Or are you just saying that?
I get it.
You get it?
I get it.
Oh, show. 0, negative 2 pi, and pi, or negative pi, because my domain is between negative 2 pi and 0. And notice that I have my answer choices n pi, where n is any integer, so I can be negative. Does that make sense, guys? Maya, does that make sense? Okay. Does that make sense? All right. Because I can be negative, like if I go clockwise, negative pi, negative 2 pi, you know what I mean?
Because negative 2 pi and 0 is that's like your domain. That's where you can stay in between.
Oh, yeah. This guy right here. All right, number 6. We don't know sine 2x just yet, so this is the only one. You're going to have to do it like this, guys. And I know, it's the end of the day. Write this down. Sine 2x equals 2 sine x cosine x. We're about 2 weeks away from half angles and double angles. We still need to do composite argument properties of cosine a plus b and sine a plus b. But we're almost there. We'll be there before the end of the semester. We'll be there around turkey time. All right, here we go. Substitute. 2 sine x cosine x, that's what sine 2x is, it's a double angle, equals negative 15 cosine x. Are you okay? Take this negative 15 cosine x and move it to the left. Chuck, why are you doing that? Because you want to equal it to 0. It's a lot easier to analyze functions when they equal 0. 2 sine x cosine x plus 15 cosine x equals 0. Are we still okay? What can I factor out from these two terms? A cosine x. So you're going to have 2 sine x plus 15 equals 0. Where is cosine x equal to 0 on the unit circle? No, not a 0. Those are some of my answers. X equals pi over 2, comma 3 pi over 2. And no, y'all don't know those. That's a demerit. I'm kidding. Look at this. 2 sine x plus 15 equals 0. Guys, that will never happen. I guess you can continue. 2 sine x equals negative 15. Divide by 2, divide by 2. Sine x equals negative 15 over 2. Guys, this is a number like negative 7.5. Sine x is between negative 1 and 1. Sine x will never be larger than 1. And it will never be smaller than negative 1. And I know in physics, negative 10 is technically bigger than negative 1 because they're talking about magnitude and forces and stuff. But in math, the further left you go, the smaller you are. So the smallest is negative 1, the biggest is 1. Chav, I don't understand what you're saying. Remember when you graphed sine x? The biggest was 1, the smallest was negative 1. Also in the unit circle, the biggest is 1, the smallest is negative 1 for the y values. Cool or not cool? Okay. Are we okay, guys?
How is sine 2x like 2 sine x cosine x? Like, how would I like look at that and know like that's what that is?
Oh, that's why I told you. That's why I told you this one. We're about 2 weeks away from that.
Also,
So
you don't know what that is?
no, in the very beginning of the problem, I told you guys it is the only one like that. Sine 2x is 2 sine x cosine x. Did anyone take summer prep here? Anyone know what sine A plus B is? Through summer prep? Yeah, you guys know. Yeah, if you guys don't know this, then don't worry about it. Sine A cosine B plus cosine A sine B. And then I guess if you make this one an A, look what happens. No, but you will eventually. Oh, look, that's sine 2A, and that, in fact, equals... Oh, look, that and that are the same. 2 sine A cosine A, which is what I got you guys right here. Yeah, don't worry about it. Okay. Did I answer that question already? All right, next one. All right. There are so many ways to do this question. It's always going to be the 1s over 4, always, but I don't want to make you guys robots. So let's do it the right way. Cancel out the 2s. Cancel out the 2s. And then what Valentine's formula do you guys know? Perfect. Go ahead and get one of these by itself. So move the sine squared to the right, and I'm going to have cosine squared x equals 1 minus sine squared x. Hold on. Hey, Miss Cruz, can you buy me a water? Can you buy me a water? Buy me a water. There. Buy me 2 waters, please. Yeah, that's fine. All right, here we go. You see this cosine squared? I'm going to do a substitution. Sine squared x equals 1 minus 2 sine squared x. 1 minus sine squared x. Sorry. No wonder you guys were like, what? I just did a substitution. I'm going to move this to the left. 2 sine squared x equals 1. Are we still okay, guys? Ask me, what happened?
Sorry, where did that come from?
This is the Valentine's formula.
Yeah, I know the Valentine formula, and I know that I can go and factor it out. How did we get 2 sine squared x? I thought it was just...
I just added them, miss. I have a negative sine squared here. So I just moved it to the left. Sine squared plus sine squared. How many sine squareds do you have?
2 sine squared.
There you go. And I just have a 1 on the right hand side of the equal sign.
Okay, but what happened to the cosine squared x?
I replaced it. I replaced cosine squared with 1 minus sine squared on the right. See? This is cosine squared x.
Okay. Okay.
Yeah, you got to ask me, miss. Be brave, guys. Ask me. All right, I want to get the sine squared x by itself. What do I got to do to that 2? Divide. Sine squared x equals a half. One last move. How do I get rid of that square? Square root. Square root, square root. Sine x equals the square root of 1 is 1, and then over the square root of 2. Plus minus. Make it look like something you guys know. Times it by square root of 2 over square root of 2. And then we got this. Sine x equals plus minus square root of 2 over 2. That's as far as you got to go. On the unit circle, where am I a positive square root of 2 over 2? And where am I a negative square root of 2 over 2? All right here. Bam, 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 bam. All the ones over what? 4. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. That's if we were between 0 and 2 pi. Notice the interval. Notice the domain. Am I between 0 and 2 pi? No, I'm between negative pi and pi. So look for the ones over 4. Letter B. I know, guys, it's not the most exciting, especially if you're tired. But letter B.
Can you go back up a little bit, please?
Like that.
So the unit quiz that you signed last week, is that this one or is that?
No, that's the one that we did. Yeah, that's 3's a crowd. I was gonna do this after school, but I said there was only 3 last time, so I just went ahead and just did it in class.
So do you have to do this one too?
Yeah, this one. That's why we're doing this. Why do you think we're doing this? This is the next one. All right, here we go, guys. This one might be an issue if you don't know how to factor. If you don't know how to factor, game over. No, for real. I mean, I'm going to go slow. Y'all ready? All right, let's see. Do you know, this is similar. Do you know how to factor 2x squared plus 11x minus 6 equals 0? Okay, let me help you. All of these are factorable, by the way, all of these. There's something called the AC method, but we'll worry about that later on. We're just going to do guess and check. So I'm going to do like this. You see that 2x squared? Thank you, miss. I'm really thirsty. I appreciate you. Thank you. You see that 2x squared? There's only one way to get 2x squared. What times what? Yeah, that's the only way. 2x times x. Okay. Hold on, guys. Let me just drink some water because I'm kind of thirsty. That was good. That was good. Okay. You see the 6? There's 2 ways to get 6. Notice it's a negative 6. Notice there's a negative in the front. You either do 3 times 2, opposite signs, one's positive, one's negative, or 2 times 3, one's positive, one's negative, or you do 6 times 1 or 1 times 6, one's positive, one's negative. Cool or not cool? Okay, I'm going to do it wrong on purpose, so do not write this down. Just listen. The whole objective is to get this positive 11x. I put a 3, I put a 2. This is wrong. It's not going to do it. How do you do it? By the way, guys, the difference has to be 11. Chav, how do you know it's a difference? Because my product is a negative. The only way I can get a negative product is a positive times a negative. Do you understand that? All right, so this is how you do it. Look at the outers. 2x times 2, that's 4x. Look at the inners. 3 times x, that's 3x. Is the difference between 4x and 3x, is it 11? No, it's 1. So take it out. What about 2 and 3? Don't write this down. It's wrong. What if the 2 goes here and the 3 goes there? 2x times 3, that's 6x. 2 times x, that's 2x. Is the difference between 6x and 2x 11x? No. So it obviously has to be the 1 and 6. Let me get it wrong one more time. Let me see which one is the right one and wrong. Okay, I'm going to put a 6 here and a 1 there. That one's wrong. Chav, how do you know it's wrong? Look at this. 2x times 1, that's 2x. 6 times x, that's 6x. The difference between 6x and 2x is 4x, so it can't be that one. See? So it takes experience. Look at this. I'm going to put the 6 here and the 1 there. That one's correct. 2x times 6, that's 12x. 1 times x, that's 1x. Is the difference between 12x and 1x 11x? Yes, I want it to be a positive, so the bigger product has to be bigger. Plus, and then this one minus. Do you guys see how we did it? Do you guys remember doing that in Algebra 2? Oh, it's the same thing, but AC method, where you multiply these two and then you expand it to a group of 4 terms and then factor by grouping. Yeah, that's fine too. All right, here we go, guys. X equals -6. -6 plus 6 is 0. 0 times anything is 0. Or x equals a half. This wasn't x, though. This was sine x. So here it is. 2, wherever there's an x, write sine. 2 sine x plus 1, or minus 1, sorry. And then sine x plus 6 equals 0. This one will never happen. Sine x will never equal -6. So you don't have to worry about that one. But this one will. Sine x will equal a half. On the unit circle, where is sine x a half? Bam. Bam. What's my answers? Yep. Power 6 and power 6. Is this helping, by the way? Are you guys sure? Okay. Oh, you need some help, Peters? Tell me, Peters. Sorry. I finished this, and I finished this in like 20 minutes, so I might have to go to the restroom in a little bit. All right. Where are we at? This one here? This is similar to 2x squared plus x minus 1 equals 0. Oh, they're being nice. They're being nice, guys. The only way you can get a 2x squared is 2x times x. The only way you can get a 1 is 1 times 1. Notice that it has to add up to a positive 1. So 2x times 1 has to be the bigger number, and this has to be the smaller number. You see how we did it? Look, 2x squared plus 2x minus x minus 1. 2x squared plus x minus 1 equals 0. See? That's what I want. It is starting to make sense, guys? Okay. All right, here we go. Let's rewrite. Here we go. Parenthesis. 2 cosine x minus 1, close, open, cosine x plus 1, close, equals 0. I just took it from that one. Well, from that, I get that cosine x equals -1, and cosine x equals half. Move 1 divided by 2. In case you don't know how I got that half, guys, all I did was this. 2 cosine x minus 1 equals 0. Move the 1. 2 cosine x equals 1. Divided by 2. Cosine x equals half. Because I see some of you guys like, huh? I don't know how you got that. So there it is. Hopefully that's good. On the unit circle, where is cosine x equal to -1? Yeah, not everyone at the same time. Pi. What about this one? What about half? It happens up here and down there. That one, I heard someone say it. That's pi over 3. What's the other one? 5 pi over 3. Good job. Look for those answers. How do we feel, guys? I know it's brutal because we're just going at it. But look, we got some easier questions. These are easier. I know. Especially fifth period, it's tough. You want the x by itself? Divide by 4. Cosine squared x equals 3/4. What's your next move? Square root. Cosine x equals law of exponents plus minus square root of 3 over 2. Bless you squared. Yeah, I'll slow down, guys. This right here just means this, square root of 3 over square root of 4. So square root of 3 over 2, and then put the plus minus. Well, because of the square root. Cool. All right, on the unit circle, I want all of them. Where am I, a positive square root of 3 over 2 or a negative square root of 3 over 2? There. All the ones over what? Over 6. They tried to trick you with letter E, but they only have half the answers. Be careful. Tricky. What are you guys going to be for Halloween? I'm going to try and be a calculator. I want to be a TI-84. I think I'm going to have to make it out of cardboard. Yeah. At the calculator? What's up, Montalongo? I'm a calculator. Or you be scared? Like, calculator. No. Why would we put blood? No. Just calculator. All right, here we go, guys. Algebra. Algebra's the issue, not pre-cal. Move the negative cosine x to the left. Factor out a cosine x. And then you're going to have cosine x plus 1. Da-da-da. Did you get that right there? Faux show. I'll stop. Cosine x equals 0. Well, in the unit circle, cosine x is 0. Where and where? Good job. Those are 2 of my answers. If I don't see those answers, take it out. Out. Maybe. Out. So now it's a 33% chance. It's either B, C, or D. Focus on the other one. Focus on the cosine x plus 1. I need that to be 0. So you don't have to write the first initial step. You could have just gone right into that. Where is cosine x equal to negative 1? Bam. What radian is that? Pi. There it is. This person got it right. I took this quiz this morning because no one has taken it yet. What time did I take it at? It was like 5. Oh, there it is. 5:31 a.m. Huh? You don't like these? You said this is literally the worst thing you've ever seen? Miss, when you love something, you also gotta love the not so exciting stuff, or else you're fake. You know. Remember that. I love my little sister. She's not always the most pleasant person to be around, but I still love her. Esmer, if you heard that, I was just joking. LOL. I have 2 little sisters, but I don't think Roxy will ever see this. Esmer probably would. All right, here we go. I'm doing the same thing as before. Do you guys even want me to do this one? Because this one's kind of the same. Okay. Move that to the left. Sine squared x plus sine x equals 0. What am I going to factor? A sine. Sine x plus 1 equals 0. And then I just find where sine x is 0. Well, in the unit circle, that happens at these 2 values. And now I'm looking at this one right here. Where is sine x equal to negative 1? What value? Yeah. Heck yeah. Find those values. Right there. Boo. It says boo. Look. Oh, you guys are fake. I'm kidding. I'm kidding. All right, go to the next question. I want you guys to be able to do this. Let me know if you can or if you can't. I want you to be able to look at this and be like, cosecant of 2x equals negative 2. Oh, the reciprocal of cosecant is sine. So I would like for you guys to be able to go right into it, leave the argument alone, and then just take the reciprocal of negative 2. Can we do that? No? Okay. If you can't do that, then do this first. Can you at least do this? Cosine of 2x is equal to 1 over, and you got to keep the argument, sine of 2x. Can we do that? Okay. Then you take this and you substitute that for cosecant 2x. 1 over sine 2x equals negative 2. So you're going to get the same answer anyways. Look, that's like negative 2 over 1. There's an equal sign in the middle. If you flip this, then you got to flip the one on the right. Sine 2x equals negative 1/2. See? I would like for you guys to be able to go there directly, but if you can't, that's fine. Do you see how we did that, guys? Okay. Next, arc sine, because this argument is not x, we have to actually do stuff to this. So write 2x, let's write it over here, because you're going to have to write a long statement. Write 2x1 equals arc sine of negative 1/2 plus 2 pi n. Well, I guess we didn't have to write it there, but the next line. Okay. Semicolon. 2x1 equals, and I'm going to wait. On the unit circle, the first time sine is a negative 1/2 is right here in quadrant 3 and then in quadrant 4. What is the answer for this angle in quadrant 3? 7 power 6, that's one of them, plus 2 pi n, semicolon, yeah, that's the next one. 2x2 equals 11 pi over 6 plus 2 pi n. We're almost done, guys. I want x1 and x2 by itself, so divide by 2, divide by 2, divide by 2. I put the 2 next to the 6 from the keep, change, flip. It's already a fraction, just put it in the bottom. Divide by 2, divide by 2, divide by 2. All right, here you go. Here's my answer. x1 equals 7 pi over 12 plus pi n, semicolon, x2 equals 11 pi over 12 plus pi n. Look at the domain. You're not going to add pi to it. Oh, yeah, no, you are. 7 pi over 12, bless you square, bless you cube. 7 pi over 12 and 11 pi over 12. Out, maybe. Oh, no, that's out of 6. Out, 1 and 7, out. 7 pi over 12, 11 pi over 12, possibly. Okay, just by looking at the answer choices, only D has those two. But I want to make sure, I want to do it the right way. Look, you see that 19 pi there, guys? Look. Just make that a 12 over 12. What's 12 plus 7? 19. There's that 19 pi over 12. Look, put a 12 pi over 12 right there. What's 12 plus 11? 12 plus 11? 23. Look, there it is. D. Do you guys see how we did it? Okay. Can we go to the next one? Bless you. Bless you squared. Bless you cubed. Let me choose blue. Bless you fourth, bless you fifth, bless you sixth, bless you seventh. The streak, Malena Flores holds the record. I think she sneezed 23 times in a row. Yeah. Text Malena Flores. Tell her that, do you remember when you sneezed 23 times in calculus? She holds the record. No, I'm being serious. She holds the record. I have the video somewhere. Yeah, because, like I was recording like this, and all you hear in the background is, choo, choo. And I just kept going. Bless you. Bless you four. Bless you fifth. Bless you six. Okay, here we go. Hey, Miss Flores. What's our time stamp? 3:04. Okay. I'm going to send her the video. We talked about you today. All right, here we go, guys. I want to solve for x. 0 to 2 pi. Move that sign out of there. How do I get it out of there? Inverse, yeah, you don't divide because it's sine of that, so you can't. There's nothing to divide. Oh, I just wrote square root of 2 over 2. Arc sine of negative square root of 2 over 2 plus 2 pi n. Can you catch it? Can you get there? Okay. Draw a unit circle. Sine is negative square root of 2 over 2 in quadrant 3 and in quadrant 4. What's the first one in quadrant 3? What rating is that? 5 pi over 4. I'll put a semicolon. X2 plus pi over 4 equals, what's the one in quadrant 4? 7 pi over 4. Good job, guys. You guys must have had a really good pre-cal teacher. Okay, I'll stop. All right, here we go. Look at this. Just subtract minus, just go minus pi over 4, minus pi over 4. 5 pi over 4 minus 1/4 pi is just pi. So I'm going to have x1, what did I write it right here? X1 equals pi plus 2 pi n, semicolon. Subtract minus pi over 4 minus pi over 4. This right here is 7 minus 1 is 6. So this is 6 pi over 4, which reduces to, oh, not everyone at the same time. Yeah, 3 pi over 2. 3 pi over 2 plus 2 pi n. All right, we got our answers. It's between 0 and 2 pi, so you're not going to be adding 2 pi to it. So my answers are pi and 3 pi over 2. It's on the next page. Yes. Oh, not even close, miss. I still need 5 more. After, I guess, because it's probably going to take a while, yours, right? After I'm done, yes. All right. You guys ready? All right, here we go. Again. Well, this is actually similar to the last one. Do you guys want me to do this one, or should we skip it? Do it? Okay, do it. All right. X over 2 minus pi over 4 equals arc cosine of 1/2 plus 2 pi n. This is just similar like the last one. Here's my unit circle. And Chav, why weren't we doing this for the other ones? Well, because the other ones had simple arguments. It just this don't have simple arguments. So you look for where cosine is a half. That's in quadrant 1 and in quadrant 4. See? That's a 1/2 comma square root of 3 over 2. And right here, that's a positive 1/2 comma negative square root of 3 over 2. All right, so here we go. I'm going to write x over 2 minus pi over 4 equals, where's the first one where cosine is a half? Pi over 3 plus 2 pi n, semicolon, x over 2 minus pi over 4 equals, what's the one in quadrant 4? That one. The denominator is also 3. 5 pi over 3, yeah. You're done with pre-cal. Now you're just doing algebra, guys. You're just doing arithmetic. So let's see. X over 2, I'm just moving that 1/4 pi to the right, equals pi over 4 plus pi over 3 plus 2 pi n, semicolon. I'm doing both at the same time. X over 2, and I guess that's subscript 1, subscript 2. You won't need this one if you think about it, but I want to do it the right way. Are we still okay? Common denominator times 3 over 3 times 4 over 4 times 3 over 3 times 4 over 4. I'm just doing common denominator, guys. X1 over 2 equals 3 pi over 12 plus 4 pi over 12 plus 2 pi n, semicolon. X2 over 2 equals 3 pi over 12 plus 20 pi over 12 plus 2 pi n. I'll slow down. You don't have to write every detail, guys. If you know what you're doing, you can just skip from one to the other. But you guys told me that you want to see more steps, so I'm just listening to what you guys told me. You guys told me you want more steps, so I'm putting more steps. Talk to the seniors. Last year, I would just I wouldn't even put steps. I would just go right into it. But you're like, we want more steps. Like, okay, here's more steps. I listen. Okay. What is 3 plus 4? So this is 4, 5, 6, 7. 7 pi over 12 plus 2 pi n, semicolon, x2 over 2 equals 20 plus 3. Not everyone at the same time. Okay. Last move. Don't worry, it's gonna be fine. Last move, just multiply by 2. Whatever you do to one side, you do to the other. Times 2 times 2. So here's what I have. x1 equals, if I multiply by 2, that 7 turns into a 14, but I'm just going to do it like this. Think about it when you distribute this 2 like this. I'll have a 2 like that. And then 2 goes into 12 6 times, see? So I'm going to have 7 pi over 6 plus 4 pi n, semicolon, x2 equals, that's gonna be 23 pi over 6 plus 4 pi n. Just this one, really. The domain is between pi over 2 and 2 pi. 23 pi over 6, guys, that's bigger than 2 pi because it's bigger than 12 pi over 6. So you don't even have to worry about that. That one's a no. No bueno. So I did all that work for nothing? No, not really. You still needed it. We're almost done, guys. We got 4 more. All right. Let me see. Are these similar? Can we do... Okay. So maybe... Well, I'll let you guys decide. Okay. I'll just tell you now. 16 and 17 are similar. See how they look? Is there one that you want me to do over the other? Or do you want me to do both? Do both? 17? Okay. 17. Go to 17. Put in here similar to 16 so you don't freak out. All right, similar to 16, divide both sides by 2. So we're going to have cosine of 3x minus pi over 4 equals negative square root of 3 over 2. Are we still okay? Okay, next move. How do I get rid of the cosine? Inverse. 3x minus pi over 4 equals arc cosine of negative square root of 3 over 2 plus 2 pi n. I don't know if you remember, but in the notes, we put a plus minus in front of the arc cosine. Do you guys remember that? I haven't been doing that at all. All right, on the unit circle, because all these have been perfect coordinates. On the unit circle, where is cosine of negative square root of 3 over 2? What happens in quadrant 2? Right here. Negative square root of 3 over 2, comma half. And it happens in quadrant 3, right here. Negative square root of 3 over 2, comma negative 1/2. So I'm going to write it like this. 3x1 minus pi over 4 equals, what's the one in quadrant 2? This radian? I heard someone say it, at least I think. Yeah. 5 pi over 6 plus 2 pi n, semicolon, 3x2 minus pi over 4 equals, what's the one in quadrant 3? Plus 2 pi n. Are we still okay, guys? All right, we're done. You're just doing arithmetic now. Move that negative pi over 4 to the right. You don't need a calculator. Equals pi over 4 plus 5 pi over 6 plus 2 pi n. In a little bit, we'll figure it out. 3x2 equals pi over 4 plus 7 pi over 6 plus 2 pi n. Okay, catch up to there. I need a common denominator. The smallest common denominator that both of them have in common is 12. Do you guys see that? Multiply this one by 3 over 3. Multiply this one by 2 over 2. Same thing with this. 3 over 3 and 2 over 2. So here we go. 3x1 equals 3 pi over 12 plus 10 pi over 12 plus 2 pi n. Don't worry, right now we'll add them up. 3x2 equals 3 pi over 12 plus 14 pi over 12 plus 2 pi n. Here we go. 3x1 equals, what's 10 plus 3? So 13 pi over 12 plus 2 pi n, semicolon. 3x2 equals 14 plus 3. So 17 pi over 12 plus 2 pi m. We're almost there. I'll slow down. Okay. Last move. What's my last move? Divide by what? Divide by 3, 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 divide by 3. X1 equals 12 times 3, 12, 24, 36. 13 pi over 36 plus 2 pi n over 3. Semicolon, x2 equals 17 pi over 36 plus 2 pi n over 3. All right, my domain is 0 to power over 2. Yeah, that one and that one. Those are within 0 to 0 and pi over 2 and 0 and half pi. Job, how do you know that's smaller than half pi? The 17 pi over 2. 17 pi over 36. What's 17 plus 17? 34? If the denominator would have been a 34, that's exactly pi over 2. Since the denominator is bigger than 34, it's smaller than a half. Does that make sense, guys? Okay. Like we know, like 1/2, 1/3. We know 1/3 is smaller than 1/2, right? Okay. Yeah. If the denominator, okay, I'll stop. Ooh, okay. Do you guys want to skip 18? I think that one's straightforward. I'll just give you a hint. Factor out of 6. And then you'll get this. Sine squared x plus 2 sine x plus 1. And then that you can factor out. Don't worry, I'll just write the factored form out. I think you guys can take it from there, right? Okay. Got it? Happy birthday. All right. I mean, that's just where is sine x equal to -1? 3 pi over 2 or negative pi over 2. Look at the domain. So, there, we practically did it right there. All right, look at this one. Actually, oh yeah, they're different. Okay, we got to do 19 because 19 is different than 20. All right, here we go. Arc sine. Pi x plus pi over 5, that's pi over 5. I don't know why UH does it that way, but that's fine. Equals arc sine of 1 plus 2 pi n. Don't worry, guys, we're almost done. We're almost done. Okay, where is sine equal to 1? At pi over 2, that's the only one. So this is only going to have one equation. Pi x plus pi over 5 equals pi over 2 plus 2 pi n. Are we okay? All right, move this pi over 5th to the right. Pi x equals negative pi over 5th plus pi over 2 plus 2 pi n. I'm going to find a common denominator, so I'm going to multiply this one by 2 over 2 and this one by 5 over 5. Bless you. Pi x equals negative 2 pi over 10 plus 5 pi over 10 plus 2 pi n. And okay, let me slow down. Negative 2 pi plus 5 pi, that is, not everyone at the same time, 3 pi over 10. We are so close, guys. How do I get x by itself? Divide by pi. Divide by pi, divide by pi, divide by pi. I should have done that a different color, right? Divide by pi, divide by pi, divide by pi. All right, here we go. X equals 3/10 plus 2n. Look at the domain. So that's just my answer, 3/10. Cool or not cool? Okay, last one. Aren't you guys happy we reached the last one? Oh. Aren't you happy, Granados? We reached the last one. How do you feel, miss? Okay, I'll stop. I want you to be happy, Miss Lopez. You doing good? Are you happy? Yeah, you had some of those grapes. The grapes? The green ones? What you think I said? And you're like, what grapes? Where do you still have some? Oh. Okay. Sorry, Miss. You know what? I'm gonna bring some grapes tomorrow. All right, here we go. Last one. I don't know why they went right to one of these, but I think they're being nice because there's only one way to get a 2 sine squared, and there's only one way to get a 7. Well, yeah, because we're at the high school level. There's only one way. It's a prime number. So here we go. Hey, no yawning. That's a demerit. 2 sine x, sine x. 2 sine x times sine x is 2 sine squared x. And there's only one way to get a 7, and they both have to be the same sign, either both positive, both negative. Since that's a plus and that's a plus, they're both going to be positive. Plus, plus. All right, where does the 7 go? Where does the 1 go? I need it to add up to a 9. Does the 7 go on the one on the right or the one on the left? The one on the left? The one on the right?
Wait. It made 14. The left.
The one on the left. See? You thought about it. Critical thinking. You decided to, look, 2 sine x times 1, that's 2. Well, that's 2 sine x. 7 times sine x, that's 7 sine x. The sum of 7 sine x and 2 sine x is 9 sine x. So we did it. You did it. Okay. Sine x equals negative 1. 2 sine x plus 7 equals 0. 2 sine x equals negative 7. Sine x equals negative 7 over 2. Not possible. Sine x will never equal negative 3.5. But this one is. Where is sine x equal to negative 1? Yeah. 3 pi over 2. How do you guys feel? Okay, I don't want to waste y'all's time. Did going over this help? Okay. Your test, let me put it here for you guys to have it. Your test will be next week. Do we have school on 11/03? Let's do it at that.